Good morning, group. I'm so glad that you were able to access the video and get your lesson today. Today's lesson is on adding and subtracting polynomials, but it's also to give you an introduction to the entire unit from here on polynomials and get an understanding of what is to be coming. As you can see on the page today, our work check for your homework is in the screen. If you would press pause and check your work so that you have that ready to turn in. If you are having any problems, you can email me and make sure that you are learning from any of your mistakes. Take the time to check your work, please. All right, we're going to move on. We're going to start with a very difficult warm-up today. In class, we would normally be taking the time to go through this problem together as partners as a warm-up to try to understand all the complexities. But for your purposes, if you would, this was on the back of the front page of your packet, remembering that we canceled out that calendar. And you are going to try to work through this problem. Now you have all of the basics needed to do so. What you are going to want to do as you go through this problem is make sure that you clean up each monomial as you progress, understanding that subtraction and addition signs are the separators. Now I want you to try this on your own before I go through it with you, and then I'm going to go ahead and go through each piece as a separate item to discuss and then how we would combine them. But go ahead and see if you can simplify the entire first line first here and then press pause. Okay, so hopefully you completed the simplification of each monomial. What we want to do here is start with the first monomial, which is from this 4 all the way to the end of this parenthesis. Now that's not really a monomial because there's an addition sign there. So I'm not going to call it a monomial, I'm going to call it a polynomial distribution simplification for this first chunk that we're going to work with. But it's still cleaning it up and make it easier to work with. So we're going to take this first part here, and we're going to distribute this 4 to the 3x and distribute the 4 to the 1/4 x cubed. That simplifies to this. We still have a separator that we bring down, and we simplify -5 squared, and we bring our separator down. And we clean up, this is a monomial, and we clean that up and we get x cubed. And there's nothing to clean up really with the y to the 4th power, so we leave that and use our separator. This one, the 4 divided by 2 is 2 on top, leaving the y squared on the bottom. That is not a monomial because the y is a variable in the bottom of the fraction. We got 10 squared, which is 100. 27 x cubed. 3 to the 3rd power is not 9. Now that was an oddity. This -1 flips the 2x below the line. So we get x divided by 2x. The x's cancel, leaving us 1/2. And then we have 2 over y squared, because the 10 to the 0 power is 1. Now you notice we use all those different exponent rules and combining like term information that we had understood in the past to get to this point. And this is just cleaning it up. We still have a lot more to do with this mess. At this point, in order to simplify this further, I want you to start training yourself to reorder. So after I explain this, I'd like you to pause. What I'd like you to do is move all of the numbers using your commutative property ordering that we learned last class. Move all the numbers to the front all of the y squared below the lines together, all of the y to the fourths together, then all of the x's together, then all of the x cubes together, and shift them so that all of the same types of monomials or non-monomials are together. So go ahead and press pause now. Okay, so hopefully you got this and you can watch as we go through. I'm going to shift my numbers with the sign that's in front of it to the front. And then, I mean, it doesn't matter what we choose exactly, but in this case I'm going with the non-x's, getting them all shifted to the front. And then the y's, and then the x's, and the x cubes. Now the standard is that we go from the highest x powers to the lowest x powers, but when we have a bunch of different variables, it doesn't really matter. Our goal is to simply make sure that we have them in order to combine like terms. So then now that we have this in this kind of order, can you combine like terms to get to your final simplified answer, which is what we would put in our answer right here. Go ahead and press pause and give that a try. Okay, so at this point you would combine your numbers. Well, these cancel each other, so that's nice, because if we had a variable in the denominator, we wouldn't be able to classify it. So those disappear. And our x cubes can combine together. And we get a simplified answer that is a 1, 2, 3, 4 part monomial. So how many monomials does it have? 4. Let's talk about degrees. Looking at it real quick. Let's look at the degrees. We have a 4 in this monomial, we have a 1 in this monomial, and a 3 in this monomial. The largest number is 4. All right, so that kind of brought everything that we've been working with together here to get us to our notes page. So go ahead and pull out your notes page. It should look like this in your packet. As we go through this today, I'm going to ask you to pause and work out a problem, pause and work out a problem. If you need separate paper, this is all notes, so just do it as we go along, just like we would in class, making sure that you take notes. This is an introduction to the next 3 lessons. Now, today's lesson will be on addition and subtraction, which you will find rather easy because we've already done or had an explanation of combining like terms, which is all it really is, with the enhancement of distribution. But this is going to introduce you to some of the new lessons that will be up and coming. Now let's start with addition. I'm going to go ahead and have you press pause here. After you do this one and this one, you can unpause and we'll discuss. Okay, so obviously 4 plus 4 you should know, and that's 8. What we want to do is group our like terms because these are numbers they can combine. And same with this one. In this case, we have no other y's, but we do have an 1x and a 1x that can be combined together to make 2x. So with that, one of the things to consider is that you're looking at addition of like terms when you're adding 2 polynomials. This is a trinomial being added to a trinomial. When it's addition, we want to make sure that we distribute everything that we have to and clean it up. Well, there's only a 1 in front of this parenthesis, so I'm distributing a 1. It just ends up being the exact same trinomial, and you can get rid of the parentheses. After you've gotten rid of the parentheses, you can order the numbers and the x values according to their powers, and then combine the like terms. So why don't you try that now? Press pause. Okay, and hopefully at this point you have combined your numbers, your x's, and your powers of 2 for x, making sure that you use the sign in front of the monomial as I trained you. So we got 8 minus 5 is 3. We got negative 4x, positive 2x, making negative 2x. And we have a positive 3x squared and a negative 7x squared, making negative 4x squared. Now you can order these in any order you want. If you had negative 4x squared minus 2x plus 3, perfectly acceptable. That's only a commutative property change. Unless they specifically say order from least to greatest or greatest to least, any answer is acceptable as long as the monomial has its appropriate sign in front of it. All right, let's go to subtraction. A little bit more nuance with subtraction. I want to explain why we do the distribution that you've been learning about all this time and show you the results with numbers versus the exponents. So do me a favor and look at these first two. Press pause and complete. Okay. Now, you'll notice that there is no distribution here, so this is a rather simple problem. 4 minus 2 plus 2. According to PEMDAS, we just do left to right. So 4 minus 2 plus 2 is 4. However, in this problem, according to PEMDAS, we should do everything in the parentheses first. So 2 plus 2 is 4. 4 minus 4 is 0. Why I had to do those is to really understand what is happening in this particular situation. When you are subtracting a grouping of numbers, you're actually going to distribute this negative to the 2 and distribute this negative to this 2. So if you think about this, this is really 4 minus 2 minus 2. That's the concept of distribution in a subtraction of two polynomials. In order to calculate this, because I cannot combine these unlike terms, I have to take this negative or subtraction sign and distribute it to both items in order to keep PEMDAS appropriate. So as you do these two problems, make sure that you distribute the negative to both monomials it applies to, and then see if you can solve. Press pause now. Okay, so hopefully you came up with two different answers for this. In the first scenario, x minus x is 0, and negative y minus negative y is 0, so we end up with 0. However, in this situation, when we distribute the negative, we got 2x minus 2y. So hopefully you understand why we have to distribute that negative to both of the monomials within the parentheses, all of the monomials in the parentheses. Now we're going to try to take that a step further and see if you can apply it to these two problems. Go ahead and press pause and see if you can get to the right answer. Okay, so as you work through the problem, hopefully you came up with the 4g cubed minus 2g cubed and minus 5g minus 4g would have gotten you to this result. And if you distribute that negative to all three pieces of this trinomial and then combined your like terms, you would have reached this conclusion. And if you do have any questions or clarifications, let me know. And that is the keys to today's work. Now let's take a future forecast of what's coming next week when you return and we get working on monomial times polynomials. This is, or will be, very familiar to you. This is simple distribution. We learned about distribution very early in the year. I've been working with it all year. But now we're trying to apply it to polynomials and just understand the terminology related to that distribution. So this should be a very easy problem for you. Go ahead and press pause and try this one and this one, please. Okay, so in this particular case, you got 4 to the 2, 4 to the x. So you got 8 plus 4x. In this case, the 8 gets applied to the first monomial, then the separator. Next monomial, separator. Next monomial, separator. And you would have combined your like terms. Now, in this scenario, when you have multiple variables, quite often we try to order our variables based on the alphabetical order. That just helps to make sure that we have all of the right variables in the right locations and that we've combined all of the terms that are exactly the same variable to the exact same power. All right. Why don't you take a look at this last one here, and I would, before you press pause, call to your attention that this is a -2 distribution and this is a +4 distribution. So when you go to rewrite, make sure that you distribute appropriately. Go ahead and press pause now. Okay, let's see how you did here. We distribute that 4 to all 4 parts of the 4-part monomials, and the -2 to the trinomial. And then we combine all of our like terms at the very end. And this should have been your final result. All right, so that's going to be 2 days of work just making sure that we really hammer in how to distribute the multiplication to polynomials in parentheses. Especially with subtraction. Make sure that this part, this is the #1 error students have in this entire unit, is when they see a subtraction, they forget to distribute the negative to every part of the trinomial or the binomial or whatever it applies to. Now, we're going to use all of this knowledge to step it up a bit later on, a week from now. And that's in full distribution of 2 polynomials. And this takes a little bit more understanding and is a multi-step process, but it's not terribly difficult as long as you follow it step by step. And this is just an introduction. You don't really need to know this right now. We will definitely do a lot more notes. It's just to kind of throw it out there to see that you understand it. So what we're going to do when we multiply 2 full polynomials together is we can't say that we're just going to take this and distribute it. It doesn't quite work like that. We are going to basically split this polynomial into its 2 monomials and distribute each monomial to this polynomial. So we are going to distribute the x squared to the x to the 6th. And we're going to take the x squared and we're going to distribute to the -6. Then we're going to take the 5 and distribute it to the x to the 6th. And we're going to take the +5 and distribute it to the -6. And we're going to end up with, if we have a binomial, 1, 2, 3, 4, we're going to end up with 1, 2, 3, 4 in our answer. X squared times x to the 6th is x to the 8th. X squared times -6 is -6x squared. 5 plus 5, making sure that you take the sign in front of it, times x to the 6th is 5x to the 6th, and plus 5 times -6 is -30. And this is the 4-part polynomial that we get as a result. Let's take this weird example. This is not, because it has a subtraction here, you cannot distribute this power. We're actually going to write this as two polynomials being multiplied together, because any square is itself multiplied to itself. And then we're going to use this exact same process. X squared to the x squared to the negative y squared to the x squared, negative y squared to the negative y squared, and distribute. And so we get the first monomial, second monomial, and look what happens in the middle. We get a x squared times negative y squared, and a negative y squared times an x squared, and we end up with the exact same monomial, and they can combine like terms. So, while you don't have to know this yet, just an interesting introduction to the next part of the chapter. All right, let's go back to addition and subtraction, which is our main goal today, and make sure we solidify that very well and that you understand it. Let's start with these two examples. Step by step, make sure that you identify parentheses separators. Those are the two different polynomials that are being added together in this particular case. You want to make sure that you distribute appropriately. Identify the exponents in any particular case that have to be simplified and eliminate them when possible. Multiply and distribute as appropriately, and group your like terms at the end so that you can simplify through combining like terms. So go ahead and try both of these and press pause. Right, so we have a monomial here, really one's being distributed to it. So as we separate these parenthesis polynomials and simplify them, in this particular case, one being distributed, there's no change to anything here. Because this is a plus sign, plus one being distributed isn't going to change anything within that side of the problem either. So the parentheses disappear. And now I can just simply combine my like terms. So I really don't need these two steps. It's just an understanding level that basically if it's addition, the parentheses can disappear and you can reorder all of your monomials in order to combine your like terms. A little bit different with subtraction, however. Plus sign in front of this being distributed, so there's really no change again. But in this particular case, it's a negative one being distributed into the parentheses. And you end up with your final simplified binomial. Number one problem students have with this entire unit is distributing that negative. It's going to be very easy to make that mistake, so keep it in the front of your mind at all times that if there's a minus sign or a negative with a number before any parentheses, that you're distributing the negative with the value. All right, simple refresher. Know that anytime we have the power and a variable that are exactly the same, we can combine those like terms and don't leave anything unsimplified. All right, according to FCPS, I must teach two different ways of how to do these processes. I have begun to taught you the way that I expect you to use, which is the vertical method. But there is a horizontal method that I need to at least show you. So if we're taking this polynomial and we are adding this polynomial, we can add vertically and horizontally. Okay. Vertically is like this. I like horizontally, and I misstated that earlier. The vertical method requires that you take this and place all of the exact same terms underneath each other. So This term, if it's an x squared, you must find the x squared in this polynomial and place it underneath this one. The x's have to be underneath the x's and the numbers under the numbers, and then you can add them together. So if you remember back to when we did elimination method, it's kind of the same concept. If you're adding two polynomials, you can use this method. But the reason we want to use this horizontal method and distribution is it becomes very pertinent later on as we get into factoring and reversing the process to understand how we reach the process and simplify. In addition, as we get into where variable pieces don't exist, like maybe this left side has an x squared or an x cubed, but this does not, you have to put in blank spaces when you do the vertical process, and it gets very complex, while this is very simple. You either have terms to combine or you don't. We can go through another example of the two different methods. This is an example of the vertical method where we don't have a 5x in the second scenario. You have to leave it blank. And if you don't have a number in the second scenario, you have to leave that blank. And then you add or subtract vertically. But when you subtract, you still have to distribute the negative and get to your final result. Versus our normal method that we've already been trained how to utilize. Distribute it to -1 and combine your like terms. All right. As you get into your classwork today, use the methods I taught you, the horizontal method, normal distribution method, in your work today. I have an answer key on the next page I am about to show you. This is your classwork. It's all like this. And then I have a challenge problem here for you if you'd like to play with it. Another answer key. And this video is actually a good video for you. So you can rewind to those sections as you need to. All right? So feel free to email or call with any questions. And that's the end of our lesson today.